4.5, Properties of Logarithms. The product property says that if I have a logarithm, log of b, and it's being multiplied m times n, I can split that up into separate logarithms with addition. I could say log b of m plus log b of n. The quotient property of log b of m divided by n, I can split that up in subtraction. Log b of m subtracting log b of n. Order matters. You got to make sure that m comes first and then your n. Here we have the power property. The power property log b of m raised to the n says that I can take this n and I can put it down in front and have n times log b of m. So every time I see an exponent, I'm going to bring it down in front of the logarithm. Finally, we have the change of base formula. We know that our calculator only does log 10. Well, the change of base formula allows me to evaluate other logarithms of other bases. If I have log a of b, I can change it to a base 10 and do log 10 of b divided by log 10 of a. The b is up a little bit higher than the a, the base, and I like to think about that in the fraction, that b will come first and then a. So log 10 of b divided by log 10 of a. Now I have log 10 and I can evaluate that on my calculator. Change of base. Let's practice those properties. Use properties of logs to expand each expression. Log 3 of 6x. There is multiplying. I am going to change it to addition when there's multiplying. I have log 3 of 6 plus log 3 of x. I have expanded it out. I see the quotient rule on the next one. I will be subtracting. We have log, which looks like it's going to be a base of 10, log of 3x, subtracting log y. We can also use the natural logarithm. We have ln, we have the quotient rule again. That would be ln of x to the 7th minus ln of y squared. I need to finish this because I have exponents. Now I'm going to use the power rule, and I'm going to bring that exponent down in front of the logarithm. So we have 7 ln x minus 2 ln y. Next, we have some multiplying. We have a power rule. Let's start with the multiplying and changing that to addition. Log 4 of 5 plus log 4 of x cubed plus log 4 of y. Finally, use the power rule. Log 4 of 5 plus 3 log 4 of x plus log 4 of y. So we can take logarithms and we can expand them. We can take logarithms and put them back under a single logarithm. Use the property of logs to condense each expression, write as a single logarithm. Okay, there's nothing in front. You're working backwards. Notice that when we were expanding these out, the power rule always came last. So that's what I should be looking for first. Is there a power rule? And then put it back together. Here I see that there's no number out front, so there was no power rule that was used. Addition means that it will go back to multiplication. Log 5 of x times x minus 3. Subtracting. There's no numbers out front. We'll go back to division, the quotient rule. The first one goes on top. We have log 6 of x plus 3 divided by x. Looking at example 7, I do see that there is a number out front. So the power rule would come first. We would have log x to the 1/2 plus log x plus 1, parentheses make a big deal, to the third power. X to the 1/2 is just a square root. I have addition. I'm going to do those at the same time. Convert this one and use the product property going back together. We have log of the square root of x times x plus 1 cubed. They are back together under a single log. Example 8, I say I have a power rule here. ln of x plus 2 raised to the second power minus ln x. Subtraction means the quotient rule, putting it under a single natural logarithm. ln of x plus 2 squared divided by x. Finally, we have the change of base, which comes in very handy. I have log 5 and I cannot evaluate that on my calculator. And what I can do is I can do a change of base. I'm going to change it to base 10. Log 10 of 50 divided by, this is on top, log 10 of 5. And I'm going to put that on my calculator. Log 50, close my parenthesis, divided by log of 5, close my parenthesis, and we get 2.43. One more. We're going to change this to log 10 of 23 divided by log 10 of 6. Close my parenthesis, divide by log 6. We get 1.75.